Hello everyone and welcome back to my YouTube channel. In the previous video, we saw what is RAG and why RAG matters. We saw what types of problems are solved using RAG. And today we are going to start vector embeddings, which is yet another most important topic in retrieval augmented generation. We'll talk about it why. So in this video, I will quickly go to the index. In this video, we are going to look at the introduction to vector embeddings. What are vector embeddings? How are vector embeddings helpful in RAG? And how are these embeddings generated? And then we'll also look at the example of a vector embedding in 3D. Okay, so I think now we can start the video. I'll start it with what we learned in the previous session, which is the RAG approach. So if you have not seen the previous video, I will suggest you to watch that video first to understand vector embedding better. But yeah, you can still continue from here. You have some data, then you have some structured, unstructured, everything data. We store it somewhere, okay? And then we saw that when user gives a query, what we do is we set the user prompt, then we fetch the relevant data. Focus on this part. We fetch the relevant data and we fetch the user prompt, user's prompt, user's query, and we fetch the relevant data and pass that to LLM. Okay, now tell me, how do we fetch this relevant data? This relevant data is fetched using vector embeddings. So the vector embeddings plays a vital role in fetching the relevant data. We'll understand step by step why, how, everything in this video. We'll also look at what are vector embeddings in 3D in this video. So make sure you watch this video till the end to understand it better. So I'll start with the first link, which is what are vector embeddings? So in short, if I have to say that you have some word, paragraph, sentence, anything, they are passed to an embedding model and they are converted, each word is converted into a vector. Let's say you pass the word hello. Hello will get converted into some vector using that embedding model, right? Similarly, if you pass dog and cat, dog, if you pass that to embedding model, it will be converted into vectors. Okay, now why are we converting words into vectors? So this embedding model is very powerful, first of all. And why are we converting our words to vectors? Because these vectors are not just simple numbers, they also have some meaning inside it. They store some meaning about the word inside themselves only. How? Let's try to understand that with a very simple example. I'll show you a detailed 3D example also later. Okay, let's try to denote these words into a 2D space. Let's say you have a 2D space. You have some words like dog and cat, apple and banana, and you have to keep them into a two-dimensional plane. What will you do? You will keep, since dog and cat both are pet, you will keep both of them closer to each other. While apple and banana both are fruit, you will not keep them closer to animals or pet. You'll keep them closer in a different position, at a different position, like this, apple and banana. But apple and banana are both fruits, so they will be closer to each other. So this is how we are able to capture some meaning. Why this is just a number, like now dog is denoted like 2 comma 3, cat is like 4 comma 5. Similarly, this is like 10 comma 12. I'm just giving random numbers. This is, let's say, 12 comma 15. These are just random numbers we use to denote these words, but they have some meaning. Dog and cat are closer to each other. Similarly, apple and banana are closer to each other because they have similar meanings. So this is why we are converting each and every word into vector so that we can capture some meaning from that word. We can at least capture which words are similar to each other, whether dog and cat are somehow similar to each other or not, whether apple and banana are similar to each other or not. So this is what we can capture. We can also capture one more thing, like I can say that dog is much closer to cat than apple, right? which means if I have to find out which one of these two are more similar to dog, I'll say cat, right? So these type of things we are able to capture if we represent the word into vectors, right? In real world, we don't represent it in just two dimensions. It is ideally represented in 256 dimensions. In some cases, it is also in some of the OpenAI models. They represent each and every word into 1536 dimensions to capture more and more meaning out of it. So this is what we call vector embeddings, converting the word into vector such that it has some meaning associated with it. We can capture some meaning or some data related to it. Okay. Now, if you look at this, there is one more very powerful thing called embedding model. What is this? If you remember the first session of this series, we talked about OpenAI also has an embedding API, if you remember, right? So OpenAI also provides something called embedding model. There are multiple other embedding models also in this world. For simplicity, I'm taking the example of OpenAI embedding model. What embedding model does is it helps you convert the word into vector. Okay, we know that, but how it helps, like what it does, how it is able to convert the dog into a word such that it is able to capture some meaning as well. So this model is already trained on millions and billions of words, right? So it knows which word are closer to each other in this world, which words are farther from each other, which word has what meaning. It knows everything about it, so that even if you give it a new word, it knows that okay, this word is used with this word, so which means this word is should be closer to this, not this. And in the 1536 dimension, whatever it has, it is able to place that word there. So this is what is the role of this embedding model. I hope these two things are clear to everyone. What are vector embeddings? Then why we are converting a word into vectors? And then what is an embedding model? If these things are clear, let me quickly go through what else we are learning here, what else we have here, because this is a very good article on vector embeddings, and you can also use this to read more about it. Explains the same thing here, like a sad boy is walking. Look how sad my cat is. These are in the same plane. Similarly, a little boy is walking, a little boy is running. These are also closer to each other, right? So this is how we convert the words into vectors, and we are able to capture a meaning of it. Now, you can't just convert a single word into vector, you can convert the whole sentence into vector. Ideally, what happens when you give it a whole sentence, they are broken down into words, and then each word will have some vector, and then we combine all the vectors that we have using multiple algorithms there, and then form one common vector for this whole sentence. And that also captures the meaning of this whole sentence. So this is how it works. Okay, now let's move to the next most important things. We learned about what are vector embeddings. Now, how are embeddings helpful in RAG? If you look at the diagram of the RAG, how are embeddings helpful, right? So let's say you have a you have some data here, okay? We discussed about a lot of things in the previous session that we discussed about cancellation policy and so on, right? So let's say you have a docs about India, right? And history of India before 1950, right? You have a lot of documentation and you are doing a query on top of it, okay? Now let's say the query is when India got freedom, okay, from British, okay? Now the question is this, okay? Now in the document, it is not written like this, India got freedom. Let's say in the document, it is mentioned as India got independence in this year, okay? So now if you do a exact search that if I need the word India, I need the freedom and from British, everything here, you may not be able to find it. But Since we have stored it in vectors, we have stored our document in form of a vector, we can get similar words. We can see that, okay, here we are talking about independence, here we are asking about freedom, and here we have independence. Since both of these are similar words, we know using the vector embedding, we can find out that these two are closer to each other, which means they are similar. So we can just say that these two words are similar to each other. So we'll return this also as relevant data. Similarly, somewhere else, if someone is talking about liberty, they will pass that also as relevant context, because that is also similar to freedom, right? So this is how vector embeddings plays a vital role in a RAG pipeline, because most of the time the user's query will not be exact match in the document. Let's say you are trying to ask how many days of remote work is allowed in this organization. And in the docs, it is mentioned as you are allowed to do 2 days work from home. So it will find out that, okay, since remote and work from home are closely related, and very closely kept in the vector embedding plane, right? So that's why it will return that, okay, it knows that this data is relevant because it is closer to what the user is asking. So it will return that answer, right? It will return that output. So this is how vector embeddings plays a vital role in a RAG pipeline. Now let's move to the next part, which is the embedding example in 3 dimension. Let's see, the link is here. You can also go to the URL projectortensorflow.org. Okay. Now, let's say we try to search any word here and see what words are closer to that word. We can do that using, let's search any word, freedom, or let's say free. So there are multiple words. So let's see, free. So it says that open is the closest word to free. Then freely is also available. So when someone is talking about free, if the document is talking about available, it will treat both of them as similar, right? And it will return that also as relevant context, which makes our job easy, which makes our RAG pipeline perform better, because the document will not always have the exact data that is asked in the query, right? Similarly, if I talk about session, see, it's meeting, conference, Saturday, meetings, week. These words are closer to session. And if you look at this, that you will find that this is the three-dimensional point of view of how vectors are kept, right? Session is closely related to this, but in that plane, similarly, it has a lot of planes here. And this is all about vector embeddings. In the next video, we'll learn about vector database, and we'll look at different types of distances among between vectors and different types of search algorithms that we have. And then we'll also use code to convert a paragraph into embeddings, or a sentence or a word into embeddings, and we'll find which two words are closer to each other using cosine similarity search algorithm. So all these things we'll do in the next session. So make sure you subscribe the channel and share this video with your friends or in your college groups, so that you all learn this series together. And if you have any questions or doubts, feel free to comment on this video, and don't forget to hit that like button. And yeah, that's all for the session. Thank you. Bye. See you all in the next session.